everyone, this is Dr. Shirisha working as Associate Professor in Institute of Aeronautical Engineering College. Today we are going to see the implementation of a stack using linked list with an example as well as with the help of Python code. Let's start the process. So what do you mean by stack? Stack is a gentle linear data structure where data is stored in such a fashion that data can be removed only from the place where we have inserted the elements. That is, have a look at the structure which I have given over here. So there will be two ends. I have taken the stack to have a maximum size of 6 elements where I have access from only one side. Right. So the side which is on with the 0th index is sealed, and you can insert an element from the top or you can remove an element from the top. That is, the most recently inserted element can be removed first. So it follows the funda of LIFO, which is last in will be first out. Okay. So this is stack, basic implementation. So as soon as we insert an element into the stack, the top gets incremented. I have inserted 3 elements. The default value of top was 0. Now it is pointing to index value 2. Okay. Then the basic operations that you can perform on a stack. The basic operations are push an element, that is adding an element into a stack, pop an element, that is removing an element from the stack, to check the peak element, that is the element pointed by the top is nothing but the peak element of a stack, to retrieve that. And next is to check whether the stack is full or empty. Why we need these two functions, basically is full and is empty, are if you are working with a stack and if you want to check, if you are trying to insert an element into the stack, and if the is function is going to return true, saying that the stack is already full, then overflow condition raises. That is, we cannot insert an element into a full stack. So to check overflow condition, we use isFull function. And the next one is empty. So to check whether a stack is having elements in it or not. While popping the element from a stack, first of all, we need to check whether the stack have elements or not. If it is not having any element, then there is no point in removing any element. So to check underflow condition, we go for isEmpty function. Right? And these stacks can be implemented using an array or using a linked list. Either way we can do. When we work with arrays, we get a constraint that we have to allocate the maximum size of the stack prior starting working with it. So that particular, as if say n locations, that is n is the maximum size of the stack we declare, then n memory locations, then consecutive memory locations will be allocated for the stack to work with it. Then we can go for the condition is full, that is, if the top is pointing to the maximum index value, then we can simply say that the stack is full. But when we work with linked list, this condition does not apply. Why? Because whenever we want to push an element into the stack, simply create a node, insert the data and link it with the already existing stack. That is more than enough. So isFull, the constraint of overflow will not arise in case if you work with the linked list, if you use linked list to implement a stack. Okay, so let's see if you the operations on stack. Initially, the stack that is the top element will be pointing to -1. Right. So when I insert an element, that is push an element into the stack, it will be pointing to the 0th index value. So by incrementing the top pointer, I'm going to insert the values. So as soon as I inserted 4 elements, my top is pointing to the topmost index value, which is 5. Now you can see that the stack is full. That is visually. But how system is going to understand? So if I try to push an element again, as top is pointing to the last element in the stack, the program must say that it is an overflow condition. You are trying to insert into a bag which is already full, right? So let us look at the other side of the coin, which is pop operation. So if I pop, 35 will be removed. That is, top is going to point to the element which is just below 35, which is 11, right? If I pop 4 more elements, then my top is going to come down and it will be pointing to 21, right? So next, what if I remove even 21? Then by default, as I have removed the last element in the stack, top must come to its default value, which is -1. What will happen if I still want to remove an element? So is it possible? Not possible. Why? Because from an empty bag, how can you remove how can you pick an element? It is out of box question, right? So it is an empty stack. When you try to perform a pop operation on it, it will show underflow condition, right? So these are the two basic conditions. And at every point of time, we can retrieve the peak element. Peak element is an element which is nothing but the element pointed by the top variable. If you look at this picture, the top element is pointing to 20. So the peak element is 21, right? So let's implement a stack using linked list. So with the help of Python code, I have gone with the implementation of the stack. Okay, I have implemented it. Let's see a few animations on the same. Thereafter, I will go and show you Python code for the same. So the first and foremost thing is, when we work with linked list, we have to understand that every data is stored in terms of a node. Data is a part and parcel of a node structure. A node will have two parts, which is the data part and the next part. Data part will hold the data, whereas the next part will hold the address of the next variable, right? So the class node is designed in such a way that it constructor, whenever we create an object, its constructor will be invoked, and this constructor is going to create that node. In what way? With the two parts in it. One is the data part and the other is the next part, the address part, to be none. Why none? Because when we create a node, it is not related to any other node, or it is not related to anyone. So in the due course of writing the code, we have to build a relation, right? So initially, when we create a node, its next part will be none. This class, node class, is meant only to create a node. Let's come to the stack class. In the stack class, the basic constructor will have two parts. First part is stat. It is a pointer variable actually, which holds the address of the first node. So we all know that while working with linked list, the basic con or disadvantage is we whatever the length of that linked list may be, but we have at any point of time, we have only the first node's address in our hands. So if you want to perform an insertion operation, deletion operation, search operation, traversal, any operation, you have to start with the first node, and the first node's address is stored in stat. In various books, you'll be seeing various terminologies like the stat. They'll be using head as one of the names. The names change, but the functionality is the same. Okay, coming to as I am using linked list to work as a stack, to behave like a stack, I need to go with top variable. Top variable is nothing but the variable which holds the most recently inserted element in a stack. So initially, I have shown you that was an implementation with arrays. So it was not pointing to any indexes. it was pointing to -1. Initial value of top was -1. Once you start inserting the elements or push the elements into the stack, the pointer variable is going to get incremented. But when we work with linked list, we don't have the concept of index values. So I have to explicitly take care of top. So I have initialized it as none, right? So let's look at the operations on stack. The first and basic operation is push operation, which is nothing but insertion. So I have read the data. That is the first statement I'm going to do. And I'm going to create a node by creating an object, by calling an object of the class node, right? So there will be two cases. A case where the stack is empty and you're trying to insert a node into it, right? So have to know that the stack is empty. If it's stat, that is a stat a pointer, that is a pointer which holds the address of the first node, is empty, is none. If it is none, then we can say that the stack is empty. Else, a stack is having a handful of elements, we have to insert them, right? These are the two cases. Let me show you pictorially. So for example, this is the case where I have handful of elements and I want to insert them, right? So have a look at this one. So new node data is 20 and is at location 5000. And the stack is in this way, 21 followed by 22, right? So have to insert, right? So give a name to the first node, which is temporary. Once you give that name to it, so you just and the first node will be the top also. So I'm going to insert the element as the first element at the beginning. So the first element will be the top element. You can do it in either way, guys. You can insert that element as the last element and say that it is the top element. We can do in that way and in this way also. I have chosen for animation this way where the first element will be the element on the top, right? Have a look at this one. So 2000, the element, the new node which is at location 5000 is inserted as the first element. So have with two steps. First of all, the first address first node's address, that is temp address 2000, is placed in the next part of the new node. Thereby I have placed a link between the new node and the first node. Then as the start pointer, I know that start pointer holds the address of the first node. So I want to change the first node after insertion. So the address of the new node is placed in the start. Thereby I have broken the link between the start pointer and the first node. Now current first node is 20, which is new node. This is how I'm going to insert or push an element into a stack. Then comes the pop operation. Pop operation is nothing but removing an element, for which I need not read any values. So even here we have two cases. A case where the stack is empty. If the stack is empty, then underflow condition raises. Have to check the same. Here I have used top variable and I have checked whether its content is none or not. Even you can go with another process. Check whether start content is none or not. Even this condition prevails. If start is holding a value none, then we can say that underflow condition has occurred and written, right? That is, there is nothing to remove. Else, what if it is having a handful of elements? Even here we have two cases, guys. One case is a case where the element is the only element in the stack. That is, it is only element, that is only one element. That is, if you talk in the terms of arrays, an element at this 0th index, right? So have to know that point in cases of linked list. Very simple. Check whether the first node's next part is none. Next part is always meant to hold the address of the next node. If that is filled with none, what does that mean? It means that it is the only node. It is only one element is present in the stack. What will happen if we remove it? If we remove that, both the start and the top pointers must be reinitialized to none, saying that the stack is empty enough. After removing the only element present in the stack is empty now. And the third case is a normal case, right? A normal case where there are a handful of elements and I want to remove the element on the top. In this process, what we have seen that the first element is acting as the top element, right? So this is the piece of code to remove the first element in the stack, and temporary is the name given to the first element. After removing that, I'm going to delete it, right? So this is the pop operation. Have a look at the animation of the same. So if I want to pop, I have to remove the element 21. It is very simple. Just change the address just by changing the address of the start with the new start element is enough. So overwrite the start content 2000 with 3000. That itself tells you that the link between the start pointer and the temporary first variable is broken. Now delete temp, free the memory allocated for temp. Thereby you have removed the first element or the top element in the stack. So these are the basic two operations, right? Coming to the basic applications of stack. So evaluation of any arithmetic expression. Stacks are mostly used by the arithmetic logic unit to evaluate an infix expression. As the system does not understand infix expression, internally it is going to convert it into postfix, evaluate it, and throw the result. So these two intermediate steps for evaluation uses stacks as the data structure to store the data. Next is backtracking, delimiter checking, that is parenthesis balancing, reversing the data, processing of function calls, recursion, all the most prominent applications of a stack. So this was a brief introduction of what a stack is and how it has been implemented using linked list and few applications of stack. Now let's migrate to Python and let's see the working of Python, a stack, construction of a stack using linked list in Python environment. Let's navigate, guys. Yes, guys. Let's come back and come to Python environment. This is my Python environment. Here I am going to write the Python code for stacks using linked list. Let's open a script for the same. This is the script on which I'm going to work, right? So first of all, I'm going to write the basic statement, the comment line, which tells for what is the reason to write this program and how this program works. That is implementation of stack using linked list, right? So this is the purpose of my program. So I'd like to go for the driver code first of all, right? Driver code is the driving force for me always. I write first of all what I am expecting from this program to develop the functions, right? So let me start with a menu driven program or menu driven driver code, where a menu will be thrown to me to choose either to push, pop, or what if you want to know the peak element, then peak. So three options I'm going to give in my menu. Let's start the driver code. As Python is an object-oriented programming language, I would definitely like to leverage this concept. So I'm going to use classes for this concept. Let's start with it. So this is my stack, which is an object which I have created of the class stack. As it is a class name, it will be good if I name it as stack with a capital S, right? So stack is the name of the class, whereas my stack is the name of the object, right? Right. Next. So what are all the options I would like to have in my menu? So this is the menu which I am talking about. The first option is push, right? And then the second option is pop. I would like to see how the pop works, right? And next operation is I would like to see what is the peak element in my stack. Then these are the basic ones, and I'd like to exit if I press 4, right? So this is the menu which I'd like to have. First option is push, second is pop, third is the peak element, right? So let's give a choice to that, right? While my choice is not equal to 4, I'm going to ask repeatedly what is my choice. So choice is equal to int of input. Enter your choice. And I just want this menu driven to look quite nice, so that I'm using all kinds of separators, also slash in, right? While I'm going to repeat this, I'm going to repeat this unless a person enters 4 to quit. If the value that I have read is 1, that is my first option, which is push option. So with the help of the object, my stack, I like to call push function. Okay. And I'd like to push an element into the stack. So to push an element into the stack, I have to read that element, right? So int of input, right? So enter an element. Enter an element, right? So close it. So with each and every operation, either it can be push or pop, I want to see what is the current status of this stack. So for that, I'd like to go with a display function. So display function will help me to show what is the current status of the stack after any insertion or deletion, right? So for that purpose, what if my choice is 2? I want to pop an element now, right? My stack dot pop is the function, and as I need not pass any element with the pop operation, because by default it is going to remove the element on top, right? So I'm not going to go with any parameter, but I'd love to see what is the status of my stack after deletion, right? So I'll go for a display function, right? Yes. What if my option is 3? That is, I want to see the peak element. So just looking at the peak element is enough. I don't want to see the whole list, right? So then I'll just go with the function called peak. Even for peak, it is not required to go for any object calling. Why? Because it is not required. It is not asking for anything. You just want to see what is the element on the top. That's it. Okay, what is the next option? 3 options I have given: push, pop, and peak. And else, if somebody gives or presses something else, I'll just give a throw an user-friendly statement saying that enter proper choice or press 4 to exit. This is a user-friendly statement that to suggest you that press a proper option or press 4 to quit. Okay, so this is the menu driven program which I would like to, which I would love to build now, in which roughly I can say that push, pop, peek and display are the 4 functions which I need. So if it, and this, yeah, 4 functions I need. If at all I need something else, I'll use it. Okay guys, let's start with creating a node with the node class. And the constructor of this class is, for this constructor to create a node, I need to have a data part with it, right? So that node's data part will be filled. So self.data is equal to data, and self.next is equal to none. As I said initially, the node which we create does not have any relation with anyone, so that its address part will be filled with none. So this is the first class. Then goes my second class, which is stack. This stack is the name of the class which I have used, and its constructor goes like this: def self, right? And its constructor is, it will have only the start, which says that initially I don't hold any address. It is an address pointer, right? Now let's write functions for push, pop, peek and display. Let's start with push. I remember that I have taken push in this way, P with the capital, right? Self, and it needs a data part, right? So I have taken a data part. To push an element, I have to create a node, that is mandate. Node with the ch as a parameter, pass it to it. Now, as I said, we have 2 cases. The first case is a case where the stack is empty and the new node which you are creating will be the first element into the stack. The second case will be a case where the stack is having handful of elements. We are inserting a new element, right? So let's go with the first option. So which says if the start is equal to none, that is if the start pointer is holding none, that means it is not pointing to any node, that itself says that the stack is not started yet. So the start is holding none. Now it is an empty stack. Now we have to insert a new one into it. Let's write a code for the same. The self, feed the the start pointer with the new node's address. There builds in a relation, right? So this is the case where, a simple case where I am inserting the first element into the stack. Else but, what if you have handful of elements? So I'm going to write a code to insert an element into the last. My funda with linked list is, when I implement it, I insert the element as a last element that acts as my open end. So remove an element. If you want to insert an element, push an element, push in the last. If you want to remove an element, pop it from the last. Okay. So temp is the name I'm going to give to my first node, and I have to travel till the last node. For that, the traveling will be while temp next is not equal to none. I'll be keep on hopping. Temp is equal to temp next, right? So once I reach a node whose next part is none, that itself tells that it is the last node. So once I reach the last node, I am going to build a relation between the temporary, that is the last node, and the new node by storing the new node's address in the next part of my temporary. So I have built a relation. Now I have inserted an element into the stack, right? So this is push operation. Let's have a look at the code. I have created a node by new node by creating an object. In programming language, if I talk, I created an object of class node with a data part choice, right, which has been passed to this push function itself. Right, in the function call itself, I have passed it, and I've covered both the cases. A case where the stack is empty and I have inserted a new node, and a case where it is having few elements, right? So let's go with the next function, which is pop. As pop function is a function which does not need any index value, any value. By default, it is going to remove the last element, right? So for that, we need to take care of one situation, guys. When we pop an element, we need to check whether the stack is having any element or not. If it is not having any element, there is no point in removing the element. So I'm going to cover that issue by checking whether my stack is none or not. If it is none, I'll just print stack is empty and I'll return. Stack is empty and return, right? By saying that there's nothing to remove, right? So stack is empty. The other case, when it is having handful of elements, right? So I'm going to name the first node as temporary, right? Then even here we have two cases. What if the element which you are trying to remove, pop, is the only element in the list? If it is the only element in the list, then we have to see that the start pointer after removing the only element is filled with none. It is a special case which you need to take care of. So as soon as I give a name to my first node as temporary, I'll check whether its next part is none or not. Which next part is none or not. If it is none, if this condition prevails, if this condition turns true, then make the self start as none, saying that now the stack is empty, and return. Right? There is nothing to display over here. Or else we have to remove the as you all know, we have to remove the last element. As we are inserting any new element in the last, if I want to pop, I have to remove the last element. Let's start. So for that, I need previous, a pointer, then while temp next not equal to none, previous is equal to temp, and temp is equal to temp next. Once I reach the last node, as the address of the last but one node is in previous, that is previous is the name given to the last but one node, I'll make its next part as none. Thereby I have broken the relation between the last element and last but one element, right? So this is my code for pop, where I have covered three cases, my dear. A case where I have checked whether the stack is empty or not. If it is empty, I'll just simply say that it is empty. As we cannot perform any pop operation, I'll return. Second case is a case where stack is having only one element in it. If it is having only one element, then I have to explicitly make the start pointer as none and return. A third case is a case where the stack is having handful of elements. So I'm going to travel to the last element and I have removed it, right? So these are the three cases which are covered in case of pop operation using linked list, a stack implementation using linked list. Okay, now I'm left with the two more functions, my dear. We thought of writing four functions. We have covered push and pop. Peek and display are left. Let's go with the third one, peek. Even peek do not need any parameter to be passed. Okay, so peek is the function. If self stat is equal to none. This is the precaution which I always take. What if the stack is empty? If the stack is empty, there is no point in looking at the peak element, right? So I'm going to print the same. No peak element. There is no peak element to print, my dears, and I'll return. What if this is not the case? If it's not the case, we have handful of elements, then I'll get a name as usual, the first element as temporary, then while temp dot next not equal to none. That is, I need to travel to the last element to print the element, because that is the most recently inserted element. Okay, then temp is equal to temp next. With this loop, I'm going to reach the last node. That is, the temporary will be named to the node whose next part is none, and the node whose next part is none is the last node, right? Once I reach the last node, print, and the help of a print statement, peak element is %d, percentage of temp data. So this is a just user-friendly statement where I'm retrieving the displaying the content in my last node, right? This is my peak function, right? So with this, I have completed 3 functions. Let us go with the last function, that which is nothing but your display function. Even display function do not need any parameter to be passed, right? So let's write it. First of all, I want to check whether my stat is none or not. If it is none, the stack is empty, nothing is there to print. So print stack is empty, right? The stack is empty, and return. Else, what if it is not the case? You have elements. Give name to the first node as temporary, then start printing. Stack is, right? So while temp next not equal to none, I'm going to print the data, right? So print temporary data. I want to show the progression. So at the end, I have taken an arrow mark so that I can show a link, right? So I've taken an arrow mark. I'm going to print each and every data part in the node temp, and I'll take the hops simultaneously. Temp is equal to temp next. Once I reach the last node, I have to explicitly print its data, right? So this is the function to display. Here I have covered 2 cases. A case where the queue stack is empty, just print it and return. Else, from the first node, print till the last. The last element which you are going to display will be the topmost element. Okay, so let me save this program. Stack ll is the short form I have given. Stack using linked list, right? Let's compile it. So you can see that 3 options are given. Let me take the first option. My choice is 21. So with the push, it is going to display it also. It is displayed that the stack is having 21. Again, one more push operation, 22. Have a look at this one. The most recently inserted element is 22, which is pushed and which is inserted as the last element. One more element I'll insert and I'll show you guys. Right. Have a look. The top element is 23 now. One more push if you want. Yes. What if I remove an element? So I'll go with option number 2. So as I removed the top element, which is the most recently inserted element, 24. And I have removed the same. Have a look. Now the top element is 23. The list is having only 3 elements. So shall I do one more pop, guys? 23 will be removed. Have a look. 21 to 22. Then let's check the peak element option 3. So the peak element is 22. Right? Shall I go for one more deletion, guys? Yes. Now the stack is having only one element, which is 21. What if I remove even that element? Have a look. The stack is empty. You have removed the only element 21 in the stack, and you have made the stack as an empty stack. Right? So these are the few operations. Let me insert once again. Let me take now 31 series. One more insertion, 32. 3 I have inserted randomly. Then I'll take one more insertion, 32 now. Now the top element is 32. And one more insertion, 34. And the peak element I want to see, yes, 34. Yes, guys, this is working. And what if I want to quit? This has become a loop, right? So what if I give a random option like, say, 7? It will clearly tell me that enter a proper choice or press 4 to exit, right? So what if I give 4? Yes, I'm out of my loop or my menu. So I've come out. You can see the arrow marks have come to the result, and we have completed the execution of the program, right? So yes, guys, this is a basic functional. This program shows the basic functionality of a stack using linked list. We have performed the most prominent and mostly used functions, which is push, pop, and peak. And with the help of display function, I have displayed all the intermediate results also. Thank you, guys. I hope you understood the logic of stack and how it is implemented. Similarly, we have posted one more video on queues using linked list also. Please do follow the same. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.